So now we're going to be doing radicals and exponents. Basically, what we're going to be doing in here is using the idea of what we learned in the last unit about the rules of exponents. So, for example, the when we're multiplying, when we have an exponent to another exponent, or when we're dividing. But we're going to be applying it when the exponent is a fraction. And we're going to be using all of those rules as well as applying them on what it means with radicals. Radicals are roots, essentially. So our goals here are to be able to think about it in different ways that we normally would, think about it abstractly, using what we know to deal with the numbers, the quantitative data. Um, Construct viable arguments, meaning we're going to try to make them equal to other things, creating our own equations, and finding how the other equations of other, or looking at an equation and kind of breaking it down, which kind of has to do with this one, looking at the structure and understanding that. And explaining the definition of rational. So remember, rational means fractions, exponents, using the properties. So this is what I meant by we're using all of the properties with exponents that might have a fraction here. And we're going to connect those ideas with radicals. Rewrite expressions involving radicals and rational exponents. So we're going to go from something being in radical form, like a root or something, and writing it to rational exponents with a fraction in the exponent, or taking that fraction exponent and writing it as a root or radical. Root slash radical, I should say. So let's get started with this warm up. So I had recorded this earlier actually, and I had initially thought that this was a plus sign. It's actually a division sign, which I really wish they did this as a fraction so you could see it a lot better. So as we know from multiplication, when we multiply, we subtract the powers, as long as the base is the same. So in this case, these are both x's, so it's okay to do it. So with division, we want to subtract those powers, and we're going to get that 4. So let me grab this 4, put this in here. Let me close this out too, because that's going to have me thinking I'm using that pen. All right, so now we're going to do multiplication, which we just described is when we add the powers. So if we have 6 times, or x to 6 times x to the second, we're going to get this 6 plus 2, so we end up getting 8. All right, and the next one we have is a, I believe Edmentum calls it an exponent of an exponent. I call it an exponent to an exponent. But this idea is that we're multiplying them together. And the reason for that is we have x to the 6 times x to the 6. That's what x to the 6 squared means, which would go back to the idea of adding things together. So it's kind of like an extension of that property. Edmentum, I honestly think that all of these are very closely related. I would almost say that the division one and the multiplication one are exactly the same. Or we'll get to the one that I think is exactly the same. Notice how they don't have it here, but there's one. Oh, I'm not. We'll get to it when we get to it. I'm jumping ahead. Like I said, I recorded this earlier. And as always, if you guys are having trouble with this and it spits out the answer, make sure you're reading these. These actually explain how to do these a lot better, in my opinion. It literally tells you, hey, you're supposed to subtract, this one you're supposed to multiply, this one you're supposed to add, and so forth. All right, so now we're going to talk about how, because we're having the fractions, it makes it seem like they're different, but they're actually the same. And the introduction, I feel the introduction comes a lot earlier because we're going to do a whole section that has nothing to do with those radicals being in disguise. So let's start talking about Rational exponents. So rational, like I said before, is just this idea of a fraction with whole numbers. Um, Integers, in other words. The term is integers, they're whole numbers. So when you're dividing whole numbers, it makes it rational. So even when you get something like this point 1, I want to say, I haven't done this in a while, but I want to say that this 1 divided by 9, yep, 1 divided by 9 is 0.11111. I don't ask me how I remember that. I did that one time. I've seen it a few times actually, but I know there's a way to calculate. But even if you have a repeating number like this, it's fine. Like for example, 1/3. I really wish they would do 1/3 because that one's a lot more common. 1 divided by 3. 3. Numbers that do not that aren't rational, for example, are square roots that keep going on like forever, basically. A pi goes on forever. This doesn't have repeating numbers, so it can't be expressed by dividing numbers. All right, so let's get into having exponents that are rational. So one thing that you'll notice, I won't go over a lot of them here because they're all the same properties. For multiplying, we're adding. If we have a power to a power, power of power, we're multiplying the powers. If we're doing product of power, this is kind of like the distributive property. Because we're distributing this power, this 2, to this 9 and this x. And negative exponent, that just means that it goes to the bottom. If it's on the bottom, it goes to the top. If it's on the top, like it is here, it would go to the bottom. So top to bottom. If it's already on the bottom, it goes to the top. This one, the quotient power properties, this one is just saying we're subtracting, so very similar to power product of power properties. It's just now we're subtracting instead of adding. And this one, power of quotient property, it's basically just a distributive property again, but this time it says it's okay to do it with division. So most of that is exactly the same as how we learned it in the last lesson. They're just saying like, hey, you can apply it to these lessons. So give me a second because I know this really messes up a lot. Okay, there we go. So if we're multiplying, they have the same base. So what we're going to do here is we're still going to add the powers. We're going to take that 1/3 plus 1/5, and we're going to do the common denominator. Now, I know a lot of you guys here, lowest common denominator, but I feel that's too restrictive. It slows you guys down thinking that there's only one way to do this. There's multiple ways to do it. You just need to find a number that 3 and 5 turn into. So for example, you can do like 30 if you want. You can multiply this because 3 goes into 30 and 5 goes into 30. So you can use 30, even though a lot of you are probably thinking, well, I could just do 15. Yeah, you can do 15. That's totally fine. You can also do 60. You can do 300. Whatever works for you. I'm going to do 15. I know it's a little harder, but I'm going to do it. It's going to 5 over 15. I'm going to add 3 over 5. Now what I did was I knew 3 goes into 15, and I know 5 also goes into 15. So I multiplied 1/3 by 5 on top and on the bottom. And for 1/5, I multiplied it by 3 top and bottom. So that's usually the easiest common denominator I can think of is like, I'm going to multiply this by that. I'm going to multiply that to this. So doing that, I end up getting 8 over 15. So 5 plus 3, because when we add, we can't. Technically, we're supposed to divide first, but fractions, I don't know why, when it comes to PEMDAS, fractions we're like, you know what? Let's divide later. As long as we're dividing by the same thing, we can just add them together. It's fine. So let's see if we do get that 8 over 15. And it is. All right, so let's move on to the next one. You can see the work they did there. They don't do it in as much detail as I did it. So this next one, we notice we have the same base, so we're going to do something like 2/5 minus 1 over 10. Now, both of them can obviously go into 50, but I know 5 can go into 10, so I might as well change this 5 to 10, which I do by multiplying by 2, which means I have to multiply the top by 2 as well, and I end up getting 4 minus 1. That means I'm going to end up getting, hold on, 2, yeah, 4 minus 1, so that's going to be a 3/10. So let me see if I'm right. 2 to the 3/10, perfect. And again, you can see the work here. If ever you guys are working by yourself, really examine this. Don't just go like, hey, that's the answer, whatever, I don't care. Read this. I really hate that Edmentum doesn't want you to show your work. So now we have a power to a power. Now, whenever we have a power to a power, we know we're multiplying it, and not unlike addition. So multiplication is a little different since multiplying and dividing are the same thing. So fractions are dividing, remember that. Multiplying and dividing are the same thing, so you can just go across. When we're doing addition or subtraction, we want to divide first, so that's the reason why we can't just go straight across. Multiplying and division are the same thing, so we can just go across for this one. So 1 times 7 is 7. 4 times 2 is 8. So I get 9 to the 7/8. 9 to the 7/8. Perfect. Now let's go to the next one. So this next one, what are we looking at here? Okay, so this is nice and easy. So this one, we kind of have that, they call it the product property, or power of product property. So meaning that this is a product and we have a power. So this is basically, like I said, the distributive property, which is we're going to distribute that 1/3 to the 7 and distribute the 1/3 to the y. Cool. And now this next one, again, it's the same thing, but now with quotient. So we're going to distribute it to the 2 with a 1/5 to the 2 and distribute it to the x as well. So we end up getting, I'm guessing, this one. Yeah, I was afraid that it was 2 times 1/5, 2 and 1/5, which would look wrong. You can barely tell that it's supposed to be an exponent. I think they really should have increased the font on the 2. All right, and I think this is the last one here. So we're going to find all of them that work. So remember, if it's a negative power, it means it goes to the bottom. So this one's good to go. This one, notice how all it did was just move the negative sign. That is not what a negative exponent is, so that's wrong. This one, you can see they moved it to the bottom. However, it's negative. And this is a tricky one because they're trying to trick you in that normally they would write it as this to that. But remember what I said before, if it's on the bottom, it goes to the top. So the reason why this looks a little weird is because you never show the 1 when it's like a number like that. So this one, it looks wrong, but it's actually right. This one's at the bottom, so it goes to the top. The work that you're doing is here, not over here. This one, again, they're trying to trick us. So you see that it's negative. It goes to the bottom, but they have this negative sign right here. So that's why that's wrong. This one looks really correct. The only thing is there's an X up top. Where did this other X come from? The X to 1/7 comes from here. So this one's kind of important. You want to make sure that your placeholder is a 1. Um, because this is a 1 over here. Not necessarily because it's a 1 there, but because of the fact that you would be dividing x by something and then x wasn't there before. So just be careful with these. You can see that this one's very tricky, this one's tricky. This was like, I think, the only one that was like decent. And I would just write down anything you had trouble with. If you still have trouble understanding where negatives go, write that down. Really look at these, look at the explanations, and try to see why. This one I think is a horrible explanation because it doesn't explain anything. It's like, here's the answers, there you go. But try to look back and see why you got the ones wrong that you got wrong. Let me scroll up here. So there's a couple of tricks we can do to make things easier when we're dealing with exponents. For one, let's say we have these double threes. So that double three, that's essentially a 3 to the 1, right? Okay. So this will allow us to add it later. And this 9, well, this 9 looks very weird compared to this 3 right here, right? So one of the things, which I find it funny that Edmentum did this, they really shouldn't have done it with this because it's like, well, why don't you just reduce this 3 and this 9? But I think that is a little complex. So what we can do is let's pretend this 3 is in here for now. We only have one 3. It's like, well, this is a 3 and that's a 9. How do I change this? It's like, well, 3 is, or 9, I'm sorry, 9 is just 3 squared. So we can change that to 3 squared. So now that when we do all of our stuff here, they forgot to mention up here that 3 to the 1 is the same thing as 5 over 5. So that's how come we have this 7 over 5. 5 plus 2 is 7. So they just neglect to do that on here or in their explanation here. Um, because they're like, oh, we can do 1 plus that, but they forget to say that 1 is 5 over 5. Or 5 over 5 is 1, so we can just pretend it's a 5 over 5. And then here, now what we're going to do is I don't know why they skip the step of doing 5 over 5, but they're like, oh, we're going to take our time explaining this one. So now we're going to multiply this here. So this 2 cancels out with this 10. The 10 is then reduced to a 5. So now when we do this, we can just think it's a giant 1, or what Edmentum wants you to do is like, hey, you can subtract this and you get 0. And then anything to 0 is 1. I like to think of it in reverse. I like to think of it, we know this is 1, ergo that's why anything to the 0 is 1. So anything to 0 power is automatically 1. All right, let's get started here. So this one, notice how they're different bases. So that means we have to use that, oh, they actually say it right here. Oh, they don't. They don't give you the name. This is the product or power of product property. So that means that there's a product and then it has a power. So this is basically, like I said, the distributive property. So we have y to the 1 to the 3 halves times 4. And remember, this is basically 4 over 1. And we're going to multiply that by x negative 1 half times 4. Let me write that in better ink. I'm so sorry. X to the negative 1 half times 4. Y to the 3 halves times 4. This 2 and this 4 will reduce each other. This reduces to a 1 and that reduces to a 2. So we end up getting 3, or y to the 3 times 2. X, this 2 and this 4 reduce. So we end up getting negative 2 on that side because, well, 1 times 2 is 2. So we end up getting y to the 6. This negative on this 2 means it's going to go to the bottom. And that's how we get this y to the 6 over x squared going on here. And you can see the steps here. They explain it a little bit and they explain the power. So remember, I go brief over these, but knowing the names of these powers might help you on the test in case there's a word section for them. And as always, I always forget to do this, but please do your guided notes. It'll just help you kind of flow through it. So while you're watching this video, I do recommend going over your guided notes to make it a little smoother. And there's also a worksheet to practice some of the skills on here. All right, so the next one we'll go over is radical notation, and I will save that for part 2 of 2, so it should be part 2 of 2. Um, I hope you guys don't mind, but I've been labeling them part 1 or part 2. The only time you'll see an of how many is because it's the last video, and that's to let you know that that series is done. You know there's another one if you see there's a part and there's no of, so you know to look for the next video. So I'll try to get that recorded tomorrow.